Hi guys, and welcome to the second part of the ARewO tutorial. And before we start off, I'd like to show you a couple of examples that I actually produced using this script. For example, you may know this one from the first tutorial that was part of the preview. I modified the script so it could automatically use textures as well. And for the second part, I updated the script to include armatures. For example, this one, you can kind of animate this millipede, and the animation for that one is a lot more crude, but this was actually a lot more difficult because if you watch closely, you can see that this centipede is actually walking along a curved path, like so. So animation is not very good, but it works, and if you tweak the legs a little more, it probably would look a lot nicer. And now let's have a look at the scene that you can actually download and use with your ARewO script. Today I'm going to transform the script so it is able to handle armatures, and also it'll be able to distribute the objects that it will replicate along a path. Now you can distribute them along any kind of motion, doesn't matter, but a path is usually the most easy, I think, because first of all, if you have the path, you can see the animation without any problems. If you're just animating the object, then it's going to be a little harder. And the other thing is, if you're using a path for your offset, then you can just use a landscape like a plane and use the same path as a curve modifier in order to shape the landscape so your figures are automatically on top of your landscape. So this is pretty awesome. And as you can see, it works quite well. Our guys here are raising their swords. It's a bit shaky, it's a bit lagging. That's because there are just a lot of those guys. But it's working fine. So let's get into that. What I did here is open up the previous tutorial file. And if you haven't watched that previous tutorial, I highly recommend it. We're going to start right where the last one left off. Now, if I were just to press the run script, let's just see what happens. We'll get the monkey replicated, and it works just like that. So because I use the bpy.ops duplicate function, it will work with an armature just fine. So that's something pretty cool. But of course we want to take it a little further. For example, we want linked copies. So if we set this linked to true, the reason for that is the linked copies are very advantageous when it comes to rendering. If I press Alt D here, you can see there's a linked copy, and the reason it's linked, or the way you can see that it's linked, is it has the same data block. So this is the data block, and monkey.002, monkey.002, so it's the same thing. Also, if I were to assign a material here, you can see that it's impossible to assign this material to just one of them because they share a data block. Now this is a very cool thing because they're kind of getting treated like particles, so they render really fast, especially in cycles. They also don't use up a lot of memory. So since we want to do this, let's just have a look at what happens if I press the run script button again. Again, we get 10 copies, but if I scroll forward in time, they're all rotating at the same time. You can see it's offset because my original animation starts at frame 0. But when I run the script, my animation gets pushed forward to frame 22. So what happened here? The reason that happened is if I press Alt D with an armature selected, like so, I have to make some space here, graph editor, this has the armature 108 action. And if I click on this armature, it also has the armature 108 action. So this armature is actually much like the materials or the data block. They share an animation. Now the good news is that we can duplicate linked, or we can link, duplicate, an armature, but we can single out the animation data. So what we need to do is press U and you'll get a list, and you can choose object animation. And if I twirl down this here, you can see it did bpy.ops.object make single user type selected objects, and then you get the list again, and only the last one should be true, animation. So I don't know if there's a copy paste function here. I wish there was, because I actually typed this by hand, but I'm going to do that right now. Okay, there we go. Copy paste from my other file. Okay, so if we were to do that now, let's just see what happens. So what part of the script we're at. That worked quite well. Okay, now we got the monkeys duplicated again. Very nice. But I don't want this linear offset. Now this would be the same offset in each loop. Also don't need the offset extra, that was for a different test. Okay, which also means we don't need these 3 lines. We can just plain delete them. Now, since we want to make this script a little more sophisticated, what we'll do is we'll, let's say, pay more attention to what exactly we did before we press the run script. For example, we could use the parent object, which is an armature, or which is supposed to be an armature. It doesn't have to be, but I guess it usually is. We'll call that arm. And we want the armature to be the active object. So I'll just copy this over. And we don't need this line anymore. Now, since we don't have an OBJ, we have to be careful because we don't have an OBJ animation data. So we'll just switch that with arm. Now you notice that in the old version, the active object will be a different one in each loop. This is not the case anymore. So the old script, what it did was duplicate everything, and if I have 2 objects selected and I duplicate them, you can see that the duplication or the copy of the active object of this group here is now still the active object. So this is what the old script did. It would duplicate this, take the active object, and then move the active object. In this case, it's the other way around. We're going to define an active object, then move that one, and then copy it, and then leave this copy just where it is, and move the original object again. So let me just show you what I mean in this. So at the first loop, there will be a copy, and the original object will be moved. So that would be like so. Then at the next stop, this will be duplicated again, the copy will be left there, and the original object will be moved again. So this is, I don't know, it's basically the same thing, but in a different order. What we're gonna do is we're gonna have to find a way to distribute them in space a little better. And the way I did this was to get a path. I'll just insert a Bezier path, something like that, and maybe make it a little more crazy, something like that. Okay. Now we could make this armature move along the path and then leave copies behind on each frame. The problem with that is the armature will have a different orientation in each frame, meaning if we want all the knights to stand up straight, that wouldn't work because, let me just demonstrate, I'll insert an empty cone here and shift select the path, Control P, follow path. Now I press Alt O and RX90. Now we can see that would be the basic knight, and it is rotating as it follows the path. So those knights would stick like that, and this is not what I want. If this is what you want, you can always do that, no problem. It's actually a lot easier because you just have to skip the location part and you can just duplicate it in each frame. But that is not very sophisticated, and that's what this tutorial is all about. Now I'll press N to bring up the options here. And as I said, we want the input of the empty, or the location of the empty in each frame, as a location for our original armature. Yes. So let's have a look at the location. It's right here, -7. Let's change that to 0. And -2. Okay. So let's have a look at where this position is a couple of frames down the road. Same thing. Didn't change. See, this location here is the absolute location, or the original location, without any transform of parents whatsoever. So if I were to press Alt G, that location would be 0, 0, 0. Now if I press Alt O again, the location is still 0, 0, 0, but the empty is following along the path. Now let's set that to something more notable, like 1, 2, 3. Let's press Alt O again. Okay, 1, 2, 3. That's easy to remember. So if we were to use the script to detect the location of the empty, that wouldn't work. We need to somewhere get the global position, so the absolute position of the empty. And first I want to name this placer. Now the placer is supposed to be the placer. Well, that's why I call it that. Let's call this placer with a small p, and I'll make it the bpy.data.objects. Okay. There is no dot in between here, and now there we go. The variable placer is now the object with the name placer. And I'll already copy this line in here because we're obviously going to need it. Now if I type in placer.location, it will give me an array of 3. 1, 2, 3. 1, 2, 3. But of course, next frame, same thing, 1, 2, 3. What we need is the placer.matrix world. Now the matrix world is a 2-dimensional array. You can see it has 4 lines in this direction and 4 lines in this direction, so 16 values actually. And we'll have to look for Shift S, cursor to selected. This way, it's just a very fast way to, a very quick way to determine where our object's at, -0.210001 and -3.8, which are exactly these coordinates. Of course, this one, e to the power of 07, that is very, very small, so don't be confused because there's an 8.3 and there's a 0. That's because that's, well, if you know what the E stands for, that means just there's 7 digits before the 8 after the decimal. Okay. Now we somehow need to access these 3 numbers, and the way you do that is matrix world, and you remember arrays start with the digit 0. So the first line here is actually the 0th line. So if I say world 0, that means we're in line 0. And if I type behind that 3, that means we're in the 4th position, because that is 0, 1, 2, 3. And that is exactly this number. So what we actually need is, instead of location 1, 2, 3, we need matrix world 0, 3, matrix world 1, 3, and matrix world 2, 3. Now we could of course use 3 different lines for that, but I think it's a lot easier if we just make a quick for loop. So very quick, right here for j, because we're already using I, in range 3 colon arm dot location j equals placer dot matrix world j 3. That's it. That makes our armature jump to the global position of our placer object. But in order for it to move, we of course have to update our frame, because if we're running the script all in frame 1, not much is going to update, obviously. So we need to do that. and we'll put that right in front of here. So there are two ways to update a frame. One is bpy context current frame equals, and the other one is frame set method. The frame set method has a big advantage because if you're using the current frame equals, that means we are actually jumping to that frame, but Blender is not going to evaluate any animation data. So the scene is actually going to be that frame, but none of the keyframes, none of the path animations, none of that will be taken into account. So what we need is the setFrame method, which goes bpy dot context dot scene dot frame set, and of course we want to jump to the frame number of our loop. So in the zeroth loop it will be frame number 0. If you want to start at frame 1, which is understandable, just add a +1 here. If we're using the armature sort of as a total object, meaning we're not just leaving the previous copy behind, but we're always going back to the previous armature, that means we also have to store the children of the armature into our selection. And we could that by get children, but let's say one of the objects is not a child of the armature. So there's a much simpler way to do that. Maybe you know the word kindergarten. So this is the German word for children, because children is taken, I guess. I just don't want to take any risks, so I'll just call it the German name, Kinder. And Kinder just simply equals bpy.context.selected objects. And of course that should be an O. Okay, selected objects. Now the variable Kinder is an array which holds all the objects that were selected by the time I pressed run script. And as you know, if I duplicate an object, the new copies will be selected, and we don't want that. We want only these two objects selected. Of course the armature is part of that Kinder because it was selected, but we need it separately because this is actually the one that stores the animation data, which will be replicated in this for loop. So if we were to run the script now, it would produce a mess, because this operation here calls all the selected objects, which would be actually all the objects that we just duplicated, and where we don't have any placing or replacing action for objects that are not parented to the original armature. So what we need to do before we duplicate again, we need to deselect these objects. And this is fairly simple. All we need to do is bpy.ops.object.select all, and the select all has 3 different methods or 3 different actions. Action equals, it can either select all, deselect all, or toggle. We want to make sure nothing is selected, so we just call our action deselect. Now we only have one more problem, and that is if I have nothing selected, then the bpy ops here would duplicate nothing. So we make sure that in the end, when all is said and done, we need to reselect all our children. I'll just jump here and press 1 tab, so I'm sure I'm at the right indentation, and I'll make another one for K in, and now I have to make sure that our script is up for a variable number of children. So let's say if I make this range 2, then that would only work for 2 objects selected. So if I have a third one, like my sword, this wouldn't work. So all I need to do is to make Python count how many children or how many slots are there in the Kinder actually, and that is done by saying n and then Kinder. So len actually returns the length of the array, how many slots are used. And now Kinder, and the kth slot of Kinder should be selected. Now let's give that a try. I've typed a lot of code without testing, so I hope this is not just me. If I type a lot of code, then I'm about to make some mistakes. Let's try again, and that looked great. All I did was miss one T. That's sort of a personal best. Okay, now we have the monkeys arranged along the path, and their offset is working fine. The only problem we have is the path is very slow, so let's just quickly fix that. And you can do the path animation by default. If you don't change anything, it is done by a modifier, by an F-curve modifier. And that modifier is a generator. Now the generator works like a line in a coordinate system. For every x we have exactly one corresponding y, and that is calculated by the method of the inclination, which is this one, plus an offset in the y direction. So if I make this more steep by typing in 5, I can make this object run along the path much faster. Let's see how fast. They're still pretty slow. What we can do, of course, is increase the size of the path. That works as well. And let's test this one more time. Run script. And this is something I really don't like. By pressing undo after running the script, it erased my T that I placed in here again. So be aware of that. If you run your script, or before you press run script, after you change your text, select something. Select something and then maybe reselect or deselect it. This is to make sure that these weird arrows don't happen to you. So again, run script one more time, and that worked. There are my monkeys. And if I give myself a little more space here, I can see them rotating offset. So this is it. Script is still fairly simple, but pretty powerful. You can replicate any animation with it. You can also just use it to distribute objects in space, which is basically like the dupli-frame method, but it actually includes an armature. Now, one last thing that I thought of, and this generator here that we talked about earlier, and that doesn't have any space right now. Here we go. It doesn't use a single keyframe. So if you want an animation sort of outside the ARewO on an object that is part of this group, and you know it's a linear motion, you can use the generator to make all of these objects go along a certain, let's say, y path. Let's say all these objects are supposed to move along the y-axis at a certain speed, but they should do all kinds of other stuff disregarding the motion along the y-axis. So all you need to do is give one of your objects a generator on the y motion and then replicate it. And since the generator is generating all the positions without using a single keyframe, it will not be touched by the ARewO script. This is just something in case it comes up. It came up during some of my tests with the millipede animation. So that's it. Second chapter of ARewO. It's now fully functional, armatures, distribution and everything. We'll let you know when we finish the add-on with all the safety measurements. For example, the script should warn you that there is no placer object in the scene, instead of making half a run and already duplicating stuff, so you have a half finished script, and so on. So as soon as we're done with that, we'll let you know, and we'll make the final version of the ARewO add-on available on Blender Diplom. Until then, my name is Frederik Steinmetz, and thank you for watching.